Let us start the second part of our first Ukrainian natural language processing workshop at the ICTERI conference. Right now we will start with our keynote speaker, and it's my pleasure to introduce John McCrae to the audience. John is a lecturer and researcher at the Data Science Institute and Insight Center for Data Analytics and ADAPT Center at the National University of Ireland, Galway, and he's the leader of the unit for linguistic data. John's research interests includes ontologies, lexicon ontology interfaces, machine translation, multilingualism, under-resourced languages, and many others. Specifically, John leads and coordinates Cardamom project, and which is the main topic for his today's talk. The Cardamom project aims to close the resource gap for minority and under-resourced languages by means of deep learning-based natural language processing and exploiting similarities of closely related languages. The project extends the idea to historical languages, which can be considered as closely related to their modern form, and as such aims to provide NLP through both space and time for languages that have been ignored by current approaches. And for our organizers, for our reason, we think that it's a really good opportunity for the Ukrainian audience to listen for such talk, because still Ukrainian language, if not under-resourced, but definitely low-resourced language in terms of natural language processing. So I hope that John's talk would be of much value for our local community. So thank you, John, for joining us, and the mic is yours, please.
Okay, thank you for the introduction. Yeah, so I'm happy to be talking today. So yeah, as the intro said, I'm here leading this research group on linguistic data, the Cardamom project. So I'm going to talk a little about the Cardamom project, and then I'm also going to talk about a sort of spin-off project we did from this. Both of which in the area of working with low resource languages. So I'll start a little bit by talking about the Cardamom project. So the goal of this was really to combine kind of three different areas to try to improve natural language processing for under-resourced languages. So first of all, we looked at big data, things like the linguistic linked open data cloud and the work that's going on there. We obviously looked at deep learning, you know, we're sort of with modern NLP, so deep learning approaches are at the core. But then we're also bringing in the comparative method. So a key idea in this project is not to view languages as isolated islands or individual data silos, but to look at how, you know, related languages can be used and how we can basically use the comparative method of linguistics in order to better improve natural language processing for under-resourced languages. So at the core of it, you know, the problem we're trying to fix is this sort of resource gap that we have for natural language processing. So the idea is if you're looking at, you know, to train a natural language processing system of reasonable quality, you would need, say, a certain amount of data. And it might be the case that your well-resourced European language like German has lots of data. But it's also increasingly the case for some of the major national languages, something like Hindi, as for example, might have a lot of resources and might be over the bar. So really in this project, we're trying to look at these languages that haven't quite got enough resources. Obviously here, located in the west coast of Ireland, where we speak the Celtic language Irish. And Irish is, of course, has a comparatively small population, even in Ireland, so it doesn't quite have the resources. So Irish is a bit below the gap, a bit below this bar, but there's other languages like Scottish Gaelic, which are even less spoken, and of course, you know, very minoritized languages like this one, Pirahan, is spoken in the Amazon. So what we're trying to do is we're trying to both increase the amount of resources that are available for these languages, so lift them towards this gap, but also try to look at NLP methods that require less data. So we're also going to try to lower this bar. So it's both about raising the resources and lowering the bar, so that more languages can get over this gap and have enough resources to build a good modern NLP system. So at its core, we noticed that we use the fact that, say, languages are very similar. So I thought about trying to change this to Ukrainian and Russian examples, where there's a very similar situation, but I'm afraid I don't know very much about Slavic languages. So I wouldn't want to do this. So I'll stick with examples I know, which is Irish and Scottish Gaelic. So they're very similar languages. And what we know is that Irish speakers learn Gaelic very quickly. To be honest, they barely need any teaching at all because they're roughly mutually intelligible. So we basically had the same idea of, can we do the same for an AI? What happens if we teach an AI first? Does it then learn Gaelic better? So we might do something where we take some Irish sentence, and let's say we're doing something like machine translation. Then we'd also take the equivalent Scottish sentence. And what we see in both of these cases is that these sentences are obviously very similar. You don't need to be a speaker of those languages to see that those two sentences really match up in terms of the words. But of course, you should also note that none of those words are actually the same. Every word is different, at least one spelling. So it's not like a trivial case of we can just, train a system in Irish, because the words will be different in Scottish. We need to understand also how the Scottish Gaelic words have changed between these two languages. As I said, this is something that I think we could also see applying in the context of using, say, Russian training data and Ukrainian training data together. So this kind of transfer learning is kind of really core to the approach that we use in Cardamom. So we're looking at kind of 4 language groups within this project. So we're looking primarily at the Celtic languages and the Germanic languages in Europe. This is because we're based in Ireland, and Irish and English are the major languages here. And so we have lots of trained data, but also, languages with a wide spread of languages. There's some very obviously well-established languages like English and German, and then lots of minority languages like, Frisian and Scots and Bavarian, for example. And also there's a focus on this project also on historical languages. I won't say too much about this today, although I guess there's some interest also in this workshop in that area. But we're looking also at historical language change. So we're looking at old forms of Irish, so old Gaelic forms, and then in the Germanic context, looking at Norse and Old English and historical forms of the languages there. So in the European context, we're looking at these. The other area we decided to look at was the Indian languages. And so there's a couple of reasons for this. One of them is that we have a lot of Indian students in our lab. So we have a lot of people who are very interested in these languages on a personal level. But also another great test case in terms of the languages, of language diversity and language relationships. So India has 2 main language families. There's a lot of other smaller language families, but the 2 big ones are the Indo-Aryan family. So this is the Indo-European branch spoken in India. So Hindi is the major language, and these derive from historical languages, particularly Sanskrit and Pali. And then in the south, there's the Dravidian family, which is non-Indo-European, so quite distinct. And Tamil is probably the biggest of these, although they're all quite under-resourced. So, we're looking at we're looking at 4 language families that have, quite different properties, and all present interesting cases where we can use our techniques of transfer learning, because many of these languages are very similar to one another, and they're often code switched among each other, particularly in the Indian languages. Speakers of some of the smaller Indian languages often code switch in Hindi and English, often both in the same sentence, which is very challenging. So how are we going about doing this? Well, our first approach, as I say, is just kind of raising the resource gap. So we're looking at data collection, and we're trying to do data collection from 3 different sources. So first of all, we're continually crawling social media. We're looking at Twitter. We're looking not so much at Facebook because it's difficult to crawl, but we're looking at Instagram and YouTube. And we're bringing data in, on a regular basis from minority language speakers on the web, so as they're using it. And we're also looking at building from the existing academic data sets. And we do this through a portal called LingHub, where we're collecting resources from different catalogs and bringing together. And finally, we're also using web crawls and trying to collect data, from websites directly. And this is all combined through a methodology called linguistic linked open data, and connects to another project I have called Pretolod, where we're doing a lot on this. As I say, for the main sort of scientific method, we're very focused on looking at language change. So here's a great example of a language change where we have a Proto-Indo-European root, pods, and then we have this, diverging into its Germanic and Latin forms. And we see in the Germanic forms, we get the words, so the modern English word of foot. And then the Dutch word, although again, it's spelt very differently, it's pronounced actually quite similar. This is foot. And then German is Fuß. So you can see, there's obviously similarities. English, Dutch, and German are much closer. There's some similarities, obviously, to the French and Latin forms. And we can model this, as it's standardly done in linguistics by looking at certain sound changes. So we know that consistently T's in Germanics change to S in modern German, and P's change to F in between Proto-Indo-European and Germanic. So these are fairly consistent changes. In fact, it's called Grimm's law. And we're trying to see this, languages not as individuals, but as a continuum with certain changes. Finally, of course, we're looking at word embeddings. So, I guess most people will know this already. You should know a word by a company it keeps, as John Firth says. So we're looking at words embedded in multi-dimensional vector spaces. And we're trying to learn relationships between them. And, things like male to female relationships and verb tenses come in here. So obviously this is then based on deep learning. So I don't know how much I need to explain this to this workshop, but the idea is we use artificial neural networks with kind of hidden layers which have this kind of deep connections, and then we learn these weights through usual approaches like SGDs. So the idea of this is to bring it into kind of a deep polylingual model. So a lot of the ways we're approaching this is by learning on multiple languages simultaneously. So the idea is if we're looking at, say, our Germanic languages, we'd be learning on English, which maybe has lots of data, and Dutch, which has less data, and then minority languages like Frisian, which is spoken in the Netherlands, and Old English, which is the historical form of the language. And what we'd see is that we'd be able to learn a single vector model that kind of maps all these words to similar spaces. So, simple words like water, which have a similar form in all three of these languages, would have a similar space, and related semantic words would come in here. So, example here, of course, is that the word dog is only in English. The other languages use some variant of the English word hound, so we'd know that that is sort of in the same space, also partly because we have the English cognate also still used with a slightly different meaning. So that's the goal. So we're trying to combine this kind of dynamic word embeddings, automatic dictionary construction, and distributional hypothesis. We're looking at building studies that look at languages changing over very long periods, so centuries to millennia, and models that use the phonetic form. So we actually care a lot about the word, how the word is written in the process of building our word embeddings. So where are we applying this? So, well, we have linguistic analysis tools, language identification, and morphosyntactic analysis, including looking at code switch analysis. So we published on sentence level language detection at Colin last year, and we're now working on doing code switch language detection. We're also going to make some kind of great tools for lexicography and for language learners. So I think it's an important part, particularly for many of the minority languages like Irish in our context, that we look at how we can improve the usage of that language by how it's learnt. I'm also very interested in historical languages and building workbenches for digital humanities. And there's one of my PhD students looking at a very old manuscript. So I'm going to talk about a project that we kind of followed on from this. So this was in the context of one of our research centers, ADAPT, and we were working with a company called Translators Without Borders, who developed vocabularies for aid workers working in crisis situations. So what they basically do is they basically provide translations, particularly looking at these minority languages. So an example is sort of the Haitian in Haiti. There was the earthquake in 2012, which devastated the country. And lots of aid workers came in and then realized that they had trouble communicating with the locals because there was virtually no resources about Haitian Creole. So this charity is there. It's a non-profit that develops resources for aid workers. And they came to us and they were like, well, we want to improve this using open data. So we looked at the open data that's available, like WordNet, Wiktionary, and Wikidata. And we tried to build ways to improve their resources. So the particular area we were looking at is related to the Rohingya refugee crisis. So this is due to the genocide that's going on in Myanmar, has displaced, over 200 million people. And the largest number of those are actually displaced into Bangladesh, this neighboring country. And Bangladesh it's a fairly linguistically diverse country. It has its national language called Bengali or Bangla. But this has a number of, dialects that are barely mutually intelligible with the main form. And in particular, of course, the refugees coming from Myanmar are mostly centered here in this green area, which has a dialect or language form called Chittagonian. So we're looking then at 5 languages. We're looking, of course, at English because this is the language the aid workers know. Bengali is the national language. Burmese is also going to be useful because it's where most of these refugees are coming from. Chittagonian, which is, of course, it's a big green area. And also the Rohingya, in fact, have their own language. So Rohingya often, the speaker form, again, related to Bengali, but different again. So what we were doing was we were trying to build these glossaries up and extend them, the existing glossaries. So it's important, for any aid program that, they have the language so they can speak with the locals. So these TWB's goal is really to provide this kind of list of localized emergency related terms. What we wanted to do was to kind of increase the number of terms, and we wanted to kind of help to discover associated terms which might be useful, which might be priorities to find translations in the local languages. So in fact, the glossaries, they look something like this. They're actually, they're really simple. They're basically CSV files with just the words. And you'll see, all kinds of vocabulary, from basic general vocabulary like month names, and then things that are maybe useful in kind of an educational context and so forth, and lots of kind of health-related terms as well. You also see, of course, that we have an issue with scripts as well, because obviously Bengali and Chittagonian are written in the Bengali Assamese script. Myanmar there's a Burmese script. And Rohingya is actually mostly written in Latin, and this is actually because most Rohingya are illiterate. So a lot of the resources have been sort of developed by well-meaning foreigners and written in Latin script rather than the Bengali Assamese script that is more common in this area of the world. So that's an interesting aspect as well. Okay, so to do this, first of all, we started working at a corpus. So for English, Burmese, and Bengali, like English, Burmese, and Bengali, this was very easy. We just went to all our usual sources: Wikipedia, the Opus Corpus Collection, Curl, which is University of Leipzig's corpus for under-resourced languages, and we found lots of text. So that was easy. Rohingya was quite challenging, but we found a very small corpus, mostly based on translations of the Quran. And for Chittagonian, well, initially we found basically nothing. And then we looked a bit harder and we found a tiny bit of Bible translation. So we use that Bible translation as a bootstrap in order to then go through Facebook and YouTube and try to find posts that contained distinctively Chittagonian words. And we use this and we put together, a corpus of Chittagonian, which is actually the first digital corpus at all, because there was nothing we could find on the web beforehand. So to give you an idea of the size of them, the Bengali and the Burmese corpus were both over 10 million words. Rohingya, we got about 100,000 words, but for Chittagonian, we're still struggling in the tens of thousands of words. So, the amount of text we have, just plain text, completely unannotated, is quite small for some of these languages. So we approach this primarily actually through linking these with other resources. So the idea is we connect their glossaries through the English with, say, Wikidata and English WordNet. So, that will then give you access from Wikidata to Wikipedia and the linked Open Data Cloud. And English WordNet connects with things like the Open Multilingual WordNet, so translations there, and the Alexis project's resources. So it's basically this kind of English monolingual linking. We did this using a tool we've been developing for a number of years called the NASH system, NASH being an Irish word meaning links. And NASH is a kind of pipeline approach where we try to take two data sets and discover kind of where they have the same things in them. So in this case, we're looking for the same words, but we also use it for things like ontologies and knowledge graphs to try to integrate them, from different domains or different business areas. So NASH is a strategy of using some initial blocking goals to try to find an early kind of set of candidate matches. And then it does NLP analysis, so it does text extraction and then text feature generation. But it also does graph analysis. It also will look at how words are related. So, using things like WordNet, or, if we're looking at resources like Wikidata, there is a kind of graph nature to it. And then we do a kind of machine learning step. And then we do actually a constraint satisfaction step, because it's important in linking that these make sense. We don't link everything to one entity, and we try to make a consistent overall linking between these tools. So this is basically the idea of how we built the system. And we used a lot of features that are fairly standard. First of all, we used this kind of battery of straightforward text features, so things like longest common subsequence, Jacquard and Dice of the words, Levenstein, and so forth. And then the other approach we used was a BERT-based Siamese deep neural network, which kind of compares the similarities using the sentence BERT model. So when we put this together, we got overall quite strong results. One of the odd things we got was that actually the less sophisticated our method, the slightly better it seemed to do. Our overall strongest result was to use just the plain text things rather than the BERT similarities, and to apply this in without much kind of fine tuning. So if we just let the model use its unsupervised mode, that seemed to do a bit better. But all the results are pretty close. We're kind of about 80% in our accuracy, which kind of coming back to the use case is something that is good enough that the aid work or the terminologist can work with it and can build on this. So to give you an example of some of the kind of informations we'd get, we would have our corpora resources, so we'd give them examples of usages in the target languages. And we're given things like alternative definitions, new terms that they could consider, so expanding the English side, related terms, which could be useful, translations coming into new languages, so they could add German or French very easily. Images were very important because, as I've already said, a lot of the people who they're working with are illiterate, so adding images would be very useful for them. And of course, the Wikipedia articles would be a nice thing to help explain these terms more. We then built this into an application. So The idea is it's simply a kind of checkbox kind of thing where the terminologists could review these terms and decide whether they wanted to add this into their resource. So we built this up using a technology stack based on Sparkle and Apache Jenna. So we also included some kind of language identification work. So this is the decoding work. And what we did here, which was quite interesting, is that we looked at two very challenging data sets. So first of all, we looked at the South African Bantu languages data set. So this is a group of 11 languages. 2 of them are Indo-European, but the other 9 are roughly mutually intelligible. So, something very close to each other. And then we actually looked at Swiss German. So this isn't distinguishing standard German from Swiss German. It was actually to do with individual dialects within Switzerland. So these are very close languages and they're very challenging to identify. And we actually found that we could improve the performance, quite significantly. So compared to the best model, we're much better in terms of this. And we even looked at doing this in a fully unsupervised mode. So we had a supervised training where we knew what the languages are, but we also just said, there's 5 languages here, go find them. I found that we're surprisingly okay at this. So we can get some reasonable performance just looking at languages without any initial training data, which of course is quite useful when we're looking at big web corpora and we don't even know what the languages are. So overall, this project came out and it created open resources that can improve the data that TWB have. And we could do this even though these languages were very under-resourced. As I said, our naive initial searches for Chittagonian data found nothing. We had to really struggle to find Chittagonian data. So this was something very important, and we could use this to develop resources. Probably the biggest issue is actually that there were some issues with kind of the candidate matching, that we couldn't always. Some of the TWB terms simply didn't match to anything in Wikidata or WordNet, or they matched to something completely irrelevant, and that was a big challenge. So that's probably a good point to stop. So in summary, we're looking at, the Cardamom project is looking at kind of building, things that help society. A billion people in the world speak a minority language. And we're trying to help them. Help these communities, trying to help people to learn new languages, to get into contact with their history, and kind of build society at all levels. So we're doing this through natural language processing, looking at deep polylingual models, and bringing the comparative model in more majorly into modern natural language processing. But also we're hoping to then connect this with digital humanities and provide new resources and new tools. And new kind of analysis methods based on kind of distant models of reading text in order to improve sort of how humanities work. So that's everything. So thank you, and I can take some questions.
Thank you so much, John. Thank you for this overall overview of your different projects. It was really interesting. So, dear audience, do we have questions to John? Please raise your hand here in Google Meet. So while waiting for the questions from the audience, John, I'm really fascinated about this idea of having word embeddings for multiple languages at once. So probably I will try to narrow my question, but first of all, what are the main issues while training word embeddings for multiple languages?
Mm-hmm. Yeah, so I mean, there's a few approaches that have been done. So one thing that was there's kind of two ways to approach it. One is to try to do it simultaneously, which is quite challenging because often the model will understand that there are 2 different languages and just, you don't get that, you don't get the relationships coming out because the model just ends up basically separating the 2 vector spaces out. So one thing that the other approach is to train separately and then align later. often using a method called procrustes analysis, where you try to align one vector space or map one vector space into another. But then you're always sort of trying to basically project one language into another's space. So a big challenge is when you're training this is to try to get a model that will be learning together. So, taking features of both languages while it's learning, but then, actually, getting some kind of similarities between those languages and building that connection, because there is a tendency for it just to see it. If you just naively train like a, like a machine, you take a word to vec model and you just stick in some say Russian text and first some Ukrainian text, then it will learn a Russian space and a Ukrainian space, and there won't learn very much between them, other than maybe, any cases where the lemmas are the same. So that's a kind of a challenge. Quite how you do this, and build a, encourage the models to try to learn together and try to map these into the same space.
Okay, thank you. And there are some words that like the same word, but in the different language they have a totally different meaning. I mean, it's like this. If you take the sentiment, it would be like one total different sentiment. And I can, from top of my mind, take words from Ukrainian and, for instance, Czech language that they have totally opposite meaning. So it's interesting how this kind of cases could be treated in this word embedding if they have the same vector space and you have the one word, and then what would be the behavior of this word in the vector space, if I may?
Yeah, it's a good question. So I mean, these kind of issue of false friends is certainly a challenge. And when you have closely related languages, you often get this. The word has shifted meaning in a subtle way. But I would also point out, you get this even if you're looking at a single language. A word like, say, the English word wicked, as an example, can have both very positive or very negative meanings with seemingly no distinction. Wicked can be great, or wicked can be evil or wrong, So these kind of semantic, and it's often caused, particularly in closely related languages, by semantic shifts. The words are related, and therefore our methods of looking at, the kind of comparative changes will try to associate these words because it knows that they're, morphologically or orthographically related. So it is certainly something that is an issue. At the moment, my attitude is a little bit that it's a case of I don't think it's frequent enough that it's something we necessarily need to fix. But this is certainly a weakness of the method, that it would see these false friends and get tricked by false friends. When you're looking at modern language, that's kind of unavoidable. So it's certainly a challenge.
Yeah, thank you. And we have a question from Yulia Macaron. So Yulia, please go ahead.
Hi, John. I have a question about, maybe I didn't understood it from the talk, but how do you handle the multi-word sequences? So if you have, we know that sometimes you have not only many words of a phrase, but sometimes they are like in some distance in a text. So if we have the constructions that are like spread through the sentence. So what can you do in this case? And I have also the other question about phonetics. Maybe you can say, did you use it? Did you try it? Could there be any benefits of using the phonetical representation? Thank you.
Right, very nice questions. So multi-word expressions, I mean, obviously we do look at this. So, as in the context of kind of modern NLP, we're using models, contextualized models like BERT, but understand, not just a single word. We have word embedded as the base, but then you also have the encoding model, which understands how these compose. So multi-word expressions come in, obviously, through the use of models like BERT. And, some of our systems are by nature like the linking system, the Nash system I presented. I mean, that works with multi-word expressions anyway. It's always been designed this way. We obviously don't particularly develop embeddings for multi-word expressions. I know there's a lot of interesting related work. Particularly, there was a Parseme project on multi-word expressions, and I co-organized the multi-word expression workshop a few years back. So there's a lot of interesting stuff here. It's not a particular focus of this project, but it is certainly interesting. Your second question was about the use of phonetic representations. So this is something we've looked into, actually. Particularly, we looked into it in the context of our Dravidian languages, where they're written in their own scripts. And most of these Dravidian languages actually have a unique script. So each language has its own script, which meant that trying to kind of naively apply our kind of orthographic approaches doesn't work because they're using different letters. And often these scripts are actually very different. So in that case, because of the nature of these languages, we looked at mapping it to a phonetic space. And what we found was that you have to get it kind of just right. So we started off by using the International Phonetic Alphabet, because that's the standard for representing phonetics. And it turns out that was not much better than not doing anything at all, because there were just all of these subtle differences in the pronunciation that we kind of didn't want to really capture. You know, vowels that are maybe, you know, fairly close, but of course they have a different symbol in IPA, and, you know, small changes in the extra kind of things like aspiration marks and such like that came into the IPA to really, you know, cause problems or cause challenges for our machines. So we found with phonetics, we had to do a kind of more of a, what we did was we used a sort of Latin Romanization phonetics, which was much rougher, but that actually worked much better because the similarities between languages seem to come out more when using a more rough level of phonetic transcription rather than the sort of more correct one. And that was certainly something that helped. Now, we're also looking at this in context of languages that do have the same script. But, you know, sometimes it helps and sometimes it doesn't, you know. I mean, I think an obvious example is sort of, say, French to English. French and English have a lot of words that are orthographically written the same, but the pronunciation is very, very different between the French and the English pronunciation. So often phonetics can kind of, you know, particularly if it's done too precisely, can actually, you know, hide things that are more obvious from the orthographic representation.
Thank you. I'll be waiting for another questions. I have another one. So it's interesting how we can use this approach specifically while studying historical languages. And so can you bring some examples of the research result while using Cardamom project? For instance, I'm curious whether it's possible to measure how the particular word change during some time in terms of historical perspective. For instance, if we try to compare its neighborhood in vector space again, have you tried some kind of this stuff?
Yeah, so I mean, this is something we're also looking into very actively. Particularly, we're looking at this in the context of changes in the Irish language, where we have a long historical corpus. And you get these kind of semantic shifts. But one particular challenge we're again getting is orthographic changes. So tracking a single word, particularly when you're looking at it over the context of hundreds of years, is actually quite challenging because the spelling will keep shifting and the way it's written. And obviously, as you go back into more historical corpora, you also get a lot less consistency in the spelling. I think the idea that a word only has one spelling is surprisingly modern. So, you know, we have a lot of variation, and understanding all that variation as well with the challenges of looking at semantic shifts is quite difficult. Another thing we have been looking at, of course, is also dating of text. So there's a lot of historical text that we have in archives, in libraries, but we don't actually know how old they are. We only have rough guesses. So another interesting aspect is looking at the trying to figure out the date and using the linguistic features and trying to understand which linguistic features correspond to which time, and try to better date some of the texts, and even understand some of the questions of authorship as well. So again, we often know nothing about who wrote a particular bit of text, historical text. So trying to understand, does this seem like a single person writing, or are there the characteristics that would suggest there are multiple people behind this text? Is also something that we're looking at. So there's a number of interesting things in the historical linguistics fronts that we're kind of developing systems for.
I see. And have you tried to train, again, the word embeddings for one particular language, but from different historical perspective? Let's take for Irish, for instance, when it's a common vector space, but from different historical periods. And if yes, so how you then differentiate between, different years or historical. So in my vision, it's like we have this additional historical feature or access that we need to stick to. So how do you deal with this?
Yeah, so I mean, in practice, our experiments, what we do is we break our corpora up into a number of different folds, basically. So historically, so we'll have, say the first 50 years and then the next 50 years and so forth. And we've been doing exactly these experiments, looking at the different sections and seeing, if we train a model on, say, more modern version, how much loss in kind of the performance of our models do we get when we're looking at an older section. We get a nice correlation. Obviously, the more recent the text is, the better it performs. But there's also a lot of variation within that as well. Like, a particular, you might look at a particular 50 years, and then for some reason that's much harder, just because of the text, being harder. A particular challenge in working with historical text also is that there's a lot of verse rather than prose, and NLP on verse is very challenging. So this is something that is does mean that sometimes we get odd results, but it's certainly something we're looking at, and we're looking to see how you can train a language with sort of time as a parameter, so that you could change it and even potentially try to change that parameter so that you're looking at what the language might be like before your corpus exists. So can you go back to the kind of prehistory of the language? That's something we're really interested in looking into.
Yeah, thank you. Oh, we have a question from Oxy. So Oxy, please.
Yes, thank you. John, you mentioned that Gaelic speakers are talking, they're learning too fast. But I have a question about talking patterns. I mean, for me, English native speakers, they are talking too fast, very fast. Yeah, is it the problem for speech recognition machines or not? I mean,
yeah, definitely. Yeah, so speech recognition is obviously yeah, so I mean, speech recognition, can be strongly affected by the speed of the speaker. Also, of course, things like background noise, all of these things come in. For speech recognition, a well-recorded session with a nice microphone against, two people chatting in a cafe will be much different in terms of its performance. So this is certainly a challenge, yeah.
And probably we're running out of time, and I will ask probably the last question. So, John, this bunch of projects you're working on, Are you open to what kind of collaboration are you open to? So, for instance, you mentioned that your group lacks this experience probably with working with Slavic languages, and here we want to establish research in particular Ukrainian, but not only, because, for instance, in Ukraine we have other native languages, for instance, Crimean Tatar language, which is under-resourced, obviously. So are you open for any collaboration, and how it
definitely always happy to collaborate? And actually one of our team members is Russian, so we do have one team member who has some experience in this and knows this area. But yeah, we're always very interested in collaborating and seeing how our methods can be applied, you know, in different contexts, you know. So certainly, send me an email.
Okay, great. Thank you so much, and
thank
you, John, for having time joining us. It was a great pleasure to have you here.
Okay, thank you very much.
So, and then now we move on to our next